Welcome in, everybody. Happy Wednesday. We only have one day of lecture today. So Monday was President's Day. I saw some folks join the Zoom on Monday, but yeah, there was that was a holiday, so campus was closed. Monday was supposed to be lists, but we covered that last week. Today we're just going to cover something called dictionaries, which is another type of data structure. This is one of the, in my opinion, the best data structures that Python implements. So it's going to be over here in lesson number 7, right? This is the one we're going to work on today. In addition, the lab, we should be able to get this lab done as well. Right? If not, then you can take it home and finish the rest. So I'm just going to open up both of these. All right, so let's kind of preface what dictionaries kind of are. All right, so first, make sure we understand lists. Right? The lists we covered last week. So I'm just gonna briefly go over it super fast. Right, a list is a data structure. You can think of it as a linear data structure. Right? In particular, we're accessing data by using numbers. Right, so if we say to-do list 0, it'll access the first element, right, and then so on. 1 gets the second element. Right, so this is a linear data structure. Things are kind of right next to each other. Right? But when we get to dictionaries, right, it's very similar, right? It's a way of storing data, but the way we index them aren't with numbers, right? So that's the biggest takeaway for today, right? We're gonna access data without numbers. We're gonna use other types of values to access it. Before we even jump into the lesson, let's kind of give a sneak peek, right? So I'm not even gonna jump into this lesson yet. I'm just gonna open up a blank notebook. Yeah, I'm gonna open up a blank notebook. Let me just make a folder. Yeah, you don't have to do this. It's gonna be, it might be a little hard to keep up with it, but I'm gonna make a folder called Playground just so I can make a new notebook here. Yeah, I'm just gonna do like so this is a blank notebook. It's gonna be a dictionary sneak peek. So we're not gonna jump into the lesson yet. We're just gonna get kind of exposed to what this data structure lets us do. A lot of the data on the internet is represented in something called a JSON. Right? JSON, this is short for JavaScript Object Notation. This is a lot of data is organized in such a way that looks like this right here. So I'm going to pull up a JSON file. So this is a JSON representation of a person, right? So this is on Wikipedia. People can look at this up. But yeah, this is a way of organizing data. Right? See how you can think of it as a dictionary later, right? Where we have something and the definition of that something is here. Right? And we have another something, definition of that is here. Right? So in this case, Python implements this really well, right? We can actually copy and paste this whole profile. Right? So this is just a sample profile. I'm just gonna copy it, right? And then paste it into this cell right here. Okay, in particular, I do have to change a few things. For example, this true right here, this is a literal. In Python, the true literal needs to be a capital T. And then another literal right here. This is not supported in Python. They meant none. Right? Null works in other languages, but in Python they call it none. Okay, so here is someone's profile. It's just pasted here. Right? It's not really stored in something, but I can set it equal to something right here. Like, what if I say profile is equal to this? Right? So this is saying, hey, make a variable and set it equal to this whole thing right here. Right? This whole thing, everything that's within these curly braces, right? So the first curly brace is here, and then the last ending curly brace is right here. Right? So everything within it is the profile. So let's go ahead and run this. Right? So I'll press play. Okay, it didn't do anything. Right? It did do something. It created a variable It's actually a dictionary. It created a dictionary that contains this data. So let's analyze this profile, right? Let's take a look at it. So we might have seen this function before. It's called type, right? Where we can kind of tell what we're working on. So what are we working on with the profile? So I'm gonna press play right here, and we are working with a dictionary. Okay, just to verify that. That's a whole goal today. Okay, let's look at profile, right? I'm just gonna type in print profile, right, just to see what it looks like. Okay, so I'll print it, and we see that it prints it like this right here, which is kind of ugly because there's no new lines and stuff. But either way, this is this is the same thing as we pasted above, right? Just without any new lines, like without any enter keys. Right, same thing. So, but it's probably better if we look at the Jupyter Notebook representation, right? So if we don't print it and just pop it out right here, the Jupyter Notebook will just display it a little nicer, right? It's not actually being printed; it's actually just being represented because this is the last statement in the cell. Right, so same thing, right? So far we captured a dictionary. So the cool thing about dictionaries, right? Like, you remember how in lists we were able to do stuff like uh, index it by 0. Right? With lists, this means access the first element. But in dictionaries, this is not going to work, right? Dictionaries are their values are not accessed by numbers. They're instead accessed by something called a key. So in this case, there's a key called first name. So we can type in first name here as a string because that's how the key is represented. Right? So first name gives us John. Right? So if we print it, right, it's still going to be the same thing, right? John. Right? So people kind of seeing how this is like a fancy list. Okay, let's do a bit more, right? Like maybe so another key was last name, right? This is another key. So John Smith. Right? So there's multiple keys that we can access. Let me just look at the representation of this real quick. So there's one key right here. Right. So we'll talk about what keys are. They're pretty much like saying, so there's key value pairs, right? This is the key and this is the value. And here's another one. Here's another one. Right. These are all pairs separated by commas. Okay. But what do you think the size of this dictionary is? It's a little interesting, right? So a size of a dictionary typically means how many pairs are there, right? How many key value pairs? So there is a function called length, right? In Python, we could put something in it. Right? Remember we said something like hello, right? Hello, the length is 5 because that's the size of it. But what if we were to put in the dictionary, right? Profile right here. And what do you think? This is asking how many key value pairs are in here. It is kind of hard to see, right? But let's see. So length of profile is 8. Right? So that's interesting, right? Why are there 8 things in here? Right here, let me go up a bit. Let me go up to this. This is a little easier to read. Right? There's definitely more than 8 things in this profile, but in particular, it's more like 8 key value pairs. Right? So we got 1 right here. Right? So this is 1, and then this is 2, and then 3, and then 4. Right? And then here's the next one, 5. Right? 5. And then another one, 6. Yeah, 6 is right here. Right? And then 7 would be children. And then 8 would be here, spouse. Right? So you can think of this as kind of features, right? Like this is actually in machine learning and kind of social media stuff too. Right? People's profiles are kind of represented in this structure. Right? In particular, this profile has 8 features. Right? 8 features: first name, last name, whether or not they're alive, right? Age, address, phone numbers, children, and then spouse. Right? Those are 8 features. The length of this dictionary. And so it is a little hard to see, but by the end of the day, Hopefully, folks can see that. Right, so let's take it a step further, right? Like maybe folks were wondering, why? Let's look at the children right here, right? This is a whole thing, right? So let's index the children to see what's up. So I'm just gonna make a new cell and then index the children. Right, children. Press play. Okay. So the children, the value of this expression gives us this right here. This is something we covered last week. People see what this is. It's a list. Right? So we can have lists as values inside of a dictionary. So it might get a little complicated right now, but it'll make sense later. Right? Once again, this is just a sneak peek. Right? We're going to start from the beginning in just a bit. Right? So we got this, and just to verify, right? Just to verify it is a list, I'm going to use the type function, and yes, it is a list. Right? So check this out. Here's the next cool part. Right? So this is a list. So pretend this can be indexed, right? Lists can be indexed by a number. Right? So if I use an index here, 0, right, it's saying, hey, grab this whole list and grab the 0th element there. Right, so that will give us Catherine there. Right, and then next index will be 1, right, and then 2, right, and then that's Trevor. Right, if we try 3, this is probably going to be a out of bounds error because there's only, it's an out of bounds error because there's only 3 things. So 0, 1, and 2. All right. All right, people cool the sneak peek. It is a lot. This is a very big sneak peek, but that's the whole goal of today is to understand kind of how to navigate this dictionary and use it a bit. Yeah, pretty cool stuff, right? Any questions on it? Any comments? Hmm? Yeah, yeah, good question. This is still considered a list. The formatting actually doesn't even matter, right? So this is vertical, but you can treat it as this is equivalent if we got rid of the new lines, which is it might be easier. Yeah, yeah. In this case, yeah, the yeah for these initializations especially. So you can actually you can actually initialize a dictionary like this, which is kind of ugly, right? Like you could totally say you could totally do this right here. So let me make a new thing. You could totally say profile is equal to this right here, which is kind of hard to read, but so it does run, but typically we want the we want our code to look nice. So it would look nicer if we did this. Right? In this case, the the format doesn't really matter. Yeah, yeah, good question. Does the formatting matter? No, not for hard coding dictionaries nor lists. Okay, let's jump into the lesson then. I hope this was a good sneak peek. And once again, this was a sneak peek in how the internet kind of represents things. Right? A lot of your data is represented as this. Right? Wikipedia data is also represented in this right here. Mhm. Mm. Oh yeah, yeah. Good question. Is Python a good program to generate apps based off of JSON data? Yeah, yeah. Actually, yeah, it is. Yeah, it is. A lot of machine learning models do that. They a lot of the Python data science. You can actually Google up Python data science, and they will write Python programs that take data and make apps based off of it. Right? Like for example, you can take this person's data and maybe find out what to recommend them. Right? Like look at their features and then kind of figure out what they might like as recommendations. So, yeah, yeah, good questions. Yeah, this is really good stuff, right? Dictionaries, a good way of organizing data. Oh, oh no, no. So good question. What is syntax? Syntax is like a grammar rules. Oh, it's all good. Yeah, but this actually doesn't really define what syntax is. In actuality, syntax just defines how things look as like it's like in English there's grammar, right? In programming there's syntax. Yeah, so invalid syntax means that you're probably going to get a red box, like a red error, because you use improper grammar to type something. Yeah, good question. Yeah, so as we've seen, dictionaries is a really cool data structure. It's like a fancy list that we're indexing with values instead, right? In this case, there's going to be key and value. Right? I'm going to say key and value a lot today, by the way. Right? Key value pairs. Right? If I were to ask folks, what is the length of this dictionary, right, what would you say? Yeah, yeah, it should be 3, right? Let's test it. Right, so I'll copy and paste this right here. Actually, I'm just going to type it out. Right, so once again, the formatting doesn't matter with these initializations, but this first one looks better. Right, it just reads better than this next one. It's the same thing though. So uh, I'm just gonna type it out myself. Animals is equal to. Let's see. Personally, I like this syntax right here instead of. I don't like either of these. I like this one just because I'm used to C++ style braces. So yeah, animals, I'm just going to put in the first key value. Right, so key value pair, so this is a lion, and then colon, and then Panthera leo. These are just scientific names for something right here. So it's just like a list. Right? It's like data structure that's just like a list, meaning that they're separated by commas. Right? Every key value pair is separated by a comma. So I'm going to put a comma here, enter, and put in another one right here. Tiger, and then Panthera tigris. And then do another key value pair. In this case, we're only using strings. So make sure to use quotes. Right? If folks don't want to type it, you can copy and paste it, but I recommend typing it just so you can practice your typing skills a bit. Okay. This is called a declaration or initialization. We're initializing a variable called animals, and this variable stores a dictionary. Right, so let's test it. Right, so I'm just going to run it. Okay, it didn't do anything, but it did. Right, it's in the kernel. It made this variable. Right, so we can go ahead and analyze that variable. Like if we print the type of it. Right, so type of animals. Right, this is a dictionary. Oh, someone in the Zoom chat, Joe, I missed Panthera tigris. Let's see. Oh yeah, I spelled it wrong. Okay, cool. Panthera tigris. Okay, cool. Yeah, thanks for bringing that up. Okay, let's um, let's run that again. So I reinitialized it, and now the type is a dictionary. Print it. Right, it's going to do the same exact thing. It's a class dictionary. Okay, so we're just verifying the type that we're working with. All right. So we'll do a couple things and then move on to the lab. Right. In particular, we're just gonna kind of navigate the dictionary, right? Add and remove elements, and then we'll move on to the lab to make sure folks can kind of apply this stuff. We're just gonna resize some things. Right. So we can, as you saw earlier, we can access the dictionaries the dictionary values. Right, so I'm going to make another cell. You don't have to do this, but this will kind of help us visualize it. Right, so animals, once again, this is not printing. This is just showing the representation. Okay, so we got three things in here, right? Three key value pairs. Right, the dictionaries are indexed by their key. Right, so we have three keys. We have lion, tiger, and bear. Right, so we can go ahead and just access all of them. Right, so animals, and we're accessing it at lion. All right, so let's see. So this gives us Panthera leo. Right, and then similarly for the tiger, right, this gives us Panthera tigris. Right, but once again, this is not really printing. Right, it's Jupyter Notebook showing us the value of the last run statement. So I'm just going to print it so we can see everything. I should print two things now. Okay, cool. And then finally, okay, there we go. Ursus arctos. Cool. So we printed all three values using this keys. Okay. What do you think might happen if we try printing a value that doesn't exist? Right? Like, what if I used a cat as a key? Right? So this there's no such thing as a cat that key value. Right? Cat doesn't have a value, so this is going to give us some sort of index out of bounds error. Right? Remember in the lists, if we were to access something outside of the list, it would give us a out of bounds error. Right? In this case, this is very similar. Key error. Right? This is saying that this doesn't exist. Right? So there's no such thing as a value attached to it. Okay. But we can make it exist, by the way. Right? We're going to see this later, just a sneak peek. Right? We can make it exist by saying, hey, cat. Right? We can say, hey, grab this, make a key, and set it equal to something. Right? I'm just going to say feline. I'm not sure what the scientific name for it is, but I'm just going to say feline. Okay, so I'm just going to say enter. So this actually is called inserting. So this inserts a new value, right? Inserts a new key pair value because it doesn't exist. So it needs to create it, right? So then we can finally, if we were to make another cell and then look at animals, right, we can see that the dictionary has a new insert. Right, so you'll see this later. I'm kind of getting ahead. My bad for that. Okay, let's jump into those things. Oh, okay. I should have done it right here. Let me just restart this notebook, kind of, because I kind of did things out of order. So I'm just going to remove that cat thing. I'm just going to restart the notebook by, I mean, you can go to kernel and restart, but I'm just going to rerun this initialization here, right, just to reset the dictionary. Okay, cool. So our dictionary is reset. Okay, cool. We were talking about how to add elements, right? So, this doesn't exist. Animals, cat. Right? I just restarted the notebook, so that this doesn't exist, and we get a key error, right? We need one way we can insert, right? We can just say this is equal to something, right? So in this case, I'm just going to set it equal to this scientific name right here. Right, felis something. Okay, so once again, this inserts a new value, a new key pair value, I mean. Okay, there we go. And then what else? Let's see. Let's add another one. Okay. Bear. Okay. So now it's gonna. Okay, so since I'm gonna rerun the cell, this is gonna happen again, right? This very first line, and since cat already exists, it's just gonna set it equal to this again. So it's kind of redundant because I'm rerunning the cell, but it's still gonna be the same dictionary. All right, so if we look at the dictionary now, it's gonna be size of 5. I mean, size of 4. Wait, I think we're missing one. Hold up, there should be 5 items in here. Lion, tiger. Oh, no, okay. We're good. If folks are wondering what happened, oh, earlier we initialized the dictionary with bear equals to Ursus arctos. So, right, I'm just going to rerun this, right? So our animals looks like this right here. So the last one is Ursus arctos, but then later we ended up changing this value right here, right? This Ursus arctos, right? We ended up changing it in this line right here. This line. This one, we're saying, hey, grab this value, but set it equal to another one. Right, so this is not really inserting, this is replacing the value, right? Because this key pair already exists. Okay, cool. Right, yeah, just like lists, right? We're inserting and replacing things. Okay. Oh, animals not defined. Yeah, here, let me take a look real quick. Okay, moving on to this dictionary length. Right, we saw a bit of this earlier. Right, the length operator tells us how many key value pairs are there in the dictionary. So far, we have 4, right, not 8. Now, you can tell by the commas. The commas separate each pair. So let me just reset this dictionary back to the original. Right, so I'm just going to copy and paste this first one. Right, this is the original one where there are 3 key value pairs. Right, so if we print the length of it, it should give us 3. Right, we're just resetting. So just to kind of comment this out a bit, this is reinitializing the dictionary. We're just resetting it, kind of. I think I skipped over a reset button here. I kind of skipped over this, but folks will get a chance to kind of test this in your lab. Right, basically, you can delete certain key value pairs with the delete keyword, right, just like with lists. It's the same thing as lists. And we can also clear. Right? I think this is the same as a list too, right? It's a dictionary function. You can put the dictionary and then dot clear, which will delete every single thing. Right, well, we didn't use it, but you might get a chance to practice it in a bit. Okay. Cool. Let me see. I want to see if we have enough to do the first part of the lab. Let me check. Okay, we got one more thing to cover, and then we can get the first part of the lab done. Finally, there are some Boolean expressions that we can use. Once again, a Boolean is something that is true or false. Sometimes it is necessary to search a dictionary to see if something exists. Right? Because, like, what if we tried accessing something that doesn't exist? So it might be necessary to create an expression that tells us whether or not a key value pair exists, right? Like let's say we were to have this dictionary, right? This is reinitializing again. So I'm just going to reinitialize this dictionary. We can write a Boolean expression that tells us true or false, right? So this is, once again, I'm just going to comment it. This is a Boolean expression that evaluates to true or false. So in this case, it's kind of like how in the previous lessons we had like less than, greater than, equals equals. Right? In this case, we're going to use something called in. I think we did this with the lists as well. Yeah, we did do it with the list. So let's see if lion is in animals, right? This is saying, hey, is lion in animals? Right? There should be. Right? We can search a dictionary based off of the keys. This gives us true. Right? So I'm just gonna print it just so it's more explicit. Okay, so print that. Cool. Let's see if cat is in it. Right? So I'm just gonna replace this with cat. Cat is not in here, so this is gonna give us false. Right? This Boolean expression is useful for making decisions. In a future lesson, we'll see that we can branch off into different scenarios, right? Like if something doesn't exist in a dictionary, then we should do some action, right? If it does exist, then we can continue doing something. And so we'll learn about if statements later, right? But this will be inside of an if statement later, right? If cat and animals, then do something, right? Else, do something else. Okay. Once again, this is a Boolean expression. If folks aren't sure what those are, let me make sure we covered those. We covered it in operators. Right, so in the fourth lesson, operators, over here in the last five, right, these are operators that produce true or false. Right, they're not giving us numbers. Right, so less than, this is going to give us a true or false. Greater than, right, it's going to do some sort of comparison. Right, this is the same as with this right here. Right, in, right, you can think of it as like a less than, greater than, equal to, right? But in particular, this one is kind of searching the dictionary and giving us true or false. Okay, people cool with that so far? Okay, cool. We've seen key errors earlier. Right? A key error is kind of like saying the index is out of bounds. Right? You might remember with lists, if we index something outside of the list, right? Like if we had a list of size 3, but we tried indexing the sixth element, right? We get a index out of bounds error. Right? Dictionaries are similar. If we access a key that doesn't exist, then it's going to give us a whoops a key error. Right? So sloth doesn't exist in here because we never initialized it with sloth. Right? So this is a fancy way of saying index out of bounds. Right? So this is a common key error. These key errors can be protected. Right? When we're writing bigger programs, we can prevent key errors by doing a check. Right? You remember earlier here, we did something like, hey, is this in animals? Right? You can think of this as a safety. Right? So here, don't do this because we won't cover if statements yet. All right? We could the reason why we might use this expression, right? We could do something like if a sloth, right, not in animals. Right? So this is like saying if this key doesn't exist in here, then we should make it exist. Right? So I'm going to make it exist by saying animals sloth is equal to. I'm not sure what the scientific name for sloth here is. I'm just going to put Sid. Okay, Sid. And then else. All right. Once again, you don't have to do this. You can print something like sloth not in animals. Oh, yeah. I'm not going to do an else statement. If sloth not in animals, I'm just going to print sloth doesn't exist, right? And then I'm just going to say creating one, right? And then maybe, and so this one is creating one. And we could do an else, right? Else, we could say sloth does sloth already exists. Right? Sloth already exists. And then maybe just print out the value there. Animals, sloth. I'm just going to combine these right here. The value is, okay. Once again, we're not going to cover if statements today. It's going to be in the future. All right, but what happens if I run this, right? So here, let's see what it is so far, right? So before I even run it, right? So this is what the animals look like so far, right? There's only 3 key value pairs, right? So what's going to happen if I run this? Right, so a sloth, not in animals, right? This is going to be true. It's going to be true because sloth doesn't exist, right? So I'm just going to run this, right? So run. Okay, so I just ran it, and it says sloth doesn't exist. It's creating one. Okay, so it's creating one. So if I rerun this cell up here, we should see the update, right? Because we're kind of running things out of order. So I'm just going to run this, and now we see it is here, right? We're just verifying it is there. So now, what do you think is going to happen if I rerun this cell now? Right? It should print sloth already exists because this is false, right? Sloth, not in animals, it is false. So this branch will not be performed. And we're going to go down here and print sloth already exists. Value is SID. Right, just to kind of reiterate that, right, let me reset the animals. So up here, I'm just going to reinitialize this dictionary. And then down here, just to verify that we did reset it. Right, the dictionary is now reset to 3 animals, no sloth. Right, so I'm going to run this one more time, 2 more times, I mean. So 1, right, sloth doesn't exist, creating 1. Right, so this inserts, right? It inserts a new value, and then we rerun it, and then it says it already exists, right? Because we made it exist and made this false. So this is kind of ahead of the today's lesson, but it's really just to kind of connect these Boolean expressions with the key errors, right? These Boolean expressions help protect from key errors. Okay. And then another safe way we can use a dictionary has a let's see, a dictionary has a get function, right? So if we say animals, they have a get function that takes the input. It's like a safe version of indexing. So if we put something like a lion, right? See, this is the same. It's actually a little safer, right? It's a little safer. So if I make a new cell, just to show people that it's the same thing, animals. Okay, lion. Right, these 2 cells are pretty much the same expression, right? The first one is safer. Right? Why is that? Let's see. It's safer because this function does some checks in the background, right? It pretty much does the if and else checks in the background. And if I were to do something that doesn't exist, like I'm just gonna put like a dog here, right? Dog doesn't exist, right? So dog here gives us, let's see. Oh, I should have said none. So when there's nothing, Jupyter Notebook won't show us anything. Okay, so but this actually evaluates to none. But if I did it here, it's going to give us a key error. Right, so this one is safer because this evaluates to none, and this doesn't evaluate at all. Right? It just errors out, which can possibly crash a program. Okay. Yeah, errors can crash any program if there's no safety. So if you have like a big program and it errors out in the middle, typically the whole program won't run anymore. It will just terminate. Yeah, so it's a good safety, right? We just talked about 2 safety things. One safety was checking to see if there's a key error, right? Like this is a condition. This is a Boolean expression that checks for key errors, right? And another safer way is this right here, right? Like if I were to store the result in, I'm just gonna store in value, value is equal to here. Right? So it doesn't do anything, but we could print value to see what it is. Right? It is none. Right? This is safer because there's no crashes or no errors. But this one, right? If we say like value is equal to animal's dog, it doesn't even give us a chance to do it. It just says error. Right? It fails right here. So, and you know, if even if we print it, right, it's not gonna print because this first one fails and it doesn't even get a chance to the next one. So yeah, that was a good question, right? If the earlier statements have an error, will the next ones work? Typically not, unless you have safeties. Yeah, good question. Okay, so just to comment this out, a safe version, and this is kind of like a dangerous version. I use the dangerous version all the time though. But yeah, it's up to you folks. Okay, so save. Yeah. Hmm. Yeah, the get function. Hmm. Exactly. Yeah. In other words, this is dangerous because it's doing like a raw access. It's but this first one is doing like a wrapped access where the function wraps the raw, and it kind of it does a safety check in the background. It pretty much does this if statement. Right? If we look at this function, like look into the library and how it works, there's an if statement that says, oh, if it's not in there, and yeah, if it's not in there, return none. Hmm. Hmm. Yeah. Oh yeah, yeah. Good question. Why are we using parentheses here and square brackets here? It's actually just the notation of Python. So in Python, functions have parentheses, and this is not a function. It's a raw access. Yeah, yeah. That's a good question. Really good one. Okay, we just finished the first half of this lesson. I think we have enough to work on the lab. All right, so let's navigate to this lab right here. We should be able to get the first part done. Right, the first part is really asking us to kind of create and navigate a dictionary and also insert and remove elements, right? Thus resizing it. So to help folks get started on this, each cell asks us to apply a dictionary manipulation thing. Right? I recommend printing the dictionary at the end of each cell, just so you can kind of see if everything is going well. So at the bottom of each cell, maybe you can just do courses here, right? But once again, Jupyter Notebook will show us the value of the last run statement. So anything you do up here, right? This last statement will verify whether or not you did it right. Right. So similarly, right here. Oh, this one you don't really have to verify anything because it's not really manipulating it. It's just asking us to print something. Right? But then the third one asks us to manipulate the dictionary in some way. Right. So you can go ahead and verify it, right, by putting courses down here, or you could print it. Right. It's probably better to print it, but then the formatting won't be there as well. So I'm just gonna rely on Jupyter to show us. Okay, and then down here, right, add a new one. This one asks us to manipulate the dictionary again. So just put the courses here. Right, and this one is another manipulation. So courses, then here. This one isn't manipulating. It's just asking us to write a Boolean expression. So yeah, go ahead and give it a shot. Most of these questions are applying what we just learned earlier, right? So you can take a look at this lesson, but most of it is here in access, add, and remove dictionary elements. Right, that's where most of this lab can be learned from. Okay, so let's get the first half done of part one, and then later on we should be able to get part two. Oh, because Jupyter Notebook. So why did I put courses at the bottom? Because Jupyter Notebook will show us the value of the last run statement. So it'll help us verify that everything up here we did correctly. So up here we're going to create a dictionary, but then this last statement will help us display it to make sure it's all good. Yeah, when creating the dictionary. Yeah, at the top here, I'll help folks get started on this actually. So on the first one, we need to create a dictionary called courses, right? So first of all, if we run this, it's not gonna work, right? Because it says courses is not defined, right? So we need to define it. If we look at the top of the lesson, right, the way we can initialize a dictionary is by saying courses is equal to something, right? So I'm just gonna set it equal to nothing for now. Right? Courses is equal to nothing, meaning that this cell should finally run because courses is now an empty dictionary, right? So I just set courses equal to nothing. It's actually an empty dictionary. And then this last print statement just verifies it. Right? If it weren't for this print statement, we can't really verify what's happening. So yeah, good question. Oh, I commented it out to show why we did it. So yeah, you could print it too. It's like a sanity check, right? So it's, the reason why I put courses at the bottom is to sanity check our previous steps. And so all you need to do here is fill these key value pairs in, separated by commas. Okay, I'm gonna set a timer here. Yeah, give it a shot. Pause the recording here too. Okay, it's cool. So there's a couple typos actually. Um, thanks for folks on Zoom and Tiris. Yeah, thanks. So on number two, there's actually a little typo here. This one says print a key. It meant to print a value. Right, so I'm just going to change it real quick. I'm going to double click into this. This is a text cell. It's not a code cell. So this one meant to say print a value. Yeah, my bad. Right, because the key is on the left and the value. Yeah, exactly. Print a value. Okay, cool. And then the third one, there's a typo here too. It's not really a typo. It's more like a misled direction. Basically, it says change the title to Python programming for everyone. Um, so this actually doesn't make a difference. So if you want, you can just make up a new name. So you can make this up to whatever you want. Change to maybe intro to Python. Right. So yeah, just a couple typos. Thanks for putting that out. Pause recording again. Let's do this together now. So nice work on the folks who got it done. We're gonna go through this together and then finish up the rest of the lesson. So the first one asks us to initialize a dictionary. In this case, there's going to be 4 key value pairs. So I'm just going to put this one is CIS 15, and the value associated with it is Python programming for everyone. Okay, and the next one is CIS 81, and this one is Introduction to Networking. Okay, and then CIS 90, Introduction to Unix. And the last one, 75. This one is Computer Security fundamentals. Cool. So we initialized it and printed it. And yeah, it should verify that there's 4 key value pairs in here. So we should be good. All right, next one, print. All right, we did this kind of in class already, but yeah, we just accessed, right, we accessed the value. So there's accessing the value, and we're printing the value here. All right, once again, this is the key, and the value is here. So the next one asks us to change a value. Right, it wants us to change this one right here, right? CIS 15. It wants us to change this part, right? Not the key, the value. So we need to access the value and then change it, right? So we can see this in the previous, in the lesson here, right? In the previous lesson, right underneath access, add and remove, right? So take a look through here, this spot right here, right? Dictionary elements are created and they're reassigned. So take a look through that. In this case, we need to access CIS 15, right? So courses CIS 15, right? Okay, so we're accessing it, but when we put an equal sign on it, we're reassigning. Reassigning means to replace. So I'm going to change it to intro to Python, right? And then this last part will kind of print it. So we run it, and we see that the title changed. Right? The original title was Python Programming for Everyone, right? But now it's Intro to Python, right? And you could print it. It's going to look a little uglier though. So yeah, same thing. Okay, next one is really the same thing, right? Add a key value pair, right? So it's going to be the same thing because this equal sign in Python, right? If it doesn't exist, it's going to create it for us. That's a cool part in this dictionary functionalities. Right, so first of all, courses CIS 54, right? This doesn't exist, right? This would actually give us a key value, a key error. So I'll run it, it gives us a key error, right? This doesn't exist, but once we set it equal to some value, right, it's gonna make it exist. This is inserting. If it doesn't exist, it's gonna insert a new one. Right, so we'll run that, and we'll be able to display it. Right, so there we go. We added another one. Okay. There was a good question earlier about why these keys are in as a string, or like a common issue or mistake might be missing these quotes. Right? So we'll cover that in a bit, but basically, there's 2 reasons. First, we initialized it as a string. This key we initialized as a string, so when we're using it, it must be indexed as a string. And then the second reason is if it weren't for a string, it's going to treat these as a variable minus some number. Right? That this is not a variable minus some number. It's a literal string. So there's kind of 2 reasons. Okay. Next, remove a key. We didn't really cover this in a lesson, but it's down here. Right? One way we can do it is with this del, right? Delete. So we can go ahead and do a delete, and then remove the key value pair, right? Which is going to be courses and then CIS 81. Right? So that should remove it, and when we display it, it's gone. Right? It's no longer here. Okay, finally, this next one is asking us to write a Boolean expression. Right? This is like a safety check to see whether or not something already exists in it. Okay, it wants us to test if CIS 81, right, is in the dictionary. Right, so that's all we need right there. Right, so it's false. Right, it's not in it because our earlier cell deleted it. Once again, this is a safety check. In the future, this will be used for making sure the program doesn't kind of crash. Right, we want to check if it's in it before we access it. Uh, mhm. Yeah. Mhm. Yeah. Yeah, good question. There's a question about errors in cells versus errors in classic Python programming. It's the same thing, right? Yeah, it's mm, yeah, yeah. Mhm. Yeah, yeah, good question. So there's a question about if you're writing a big program, right? So this is not really classic programming. This is really just running big, like small blocks of code at a time, right? But in classic programming, in my opinion, you're writing a big file, right? Or not big files. You're writing files, and each file has different code. So, you know, a good way to avoid errors is to test frequently. We'll do this probably after the midterm. We'll do some classic Python coding. Yeah, yeah, all good. Lisa, yeah, we got a question.
Yeah. Hi, Andrew.
Yes.
Um, I got knocked off the internet for a sec, so I missed question two.
Okay. Yeah, so it's all recorded, but yeah, question two is right here. Yeah, we just used the course dictionary and printed the value at this key.
Okay. Thank
Yep,
you.
yep. Cool, cool. Well, welcome back though. Hope your internet works
Thanks.
now.
Yeah, it's
Yep,
good. Thanks.
nice. Okay. Any questions about this lab so far? The first half? Okay. Yeah, and once again, to reiterate that, we'll do some classic Python programming probably halfway in the semester. Right? This one is not really classic. It's just kind of um, pressing play and seeing what small blocks of code do. All right, so let's get back to the rest of the lesson. All right, so we need to finish up something called data structures. So let's go back to the lesson and go all the way down to data structures. This is a very big takeaway from from computer science, actually. We saw a representation of a data structure earlier. Right? At the very beginning of class, we were exposed to a JSON file, right? A way of organizing data. Right? This is a very common format on the internet. And we got exposed to this person's profile, right? Just a sample person, right? John Smith. This is a data structure, right? It's actually a dictionary with a dictionary inside of it, right? So it's going to look complicated, right? So this first key value pair, right? This is just a string and a string, right? Next one, string, string. The next one is string and then a boolean, right? A boolean literal. And next one is string and then integer, right? And the next one, this is a string and a dictionary. So we can have dictionaries as values within the dictionary. All right, so that's kind of where we get exposed to data structures, right? Things are within each other. And then the next, children, right? We got a string, and its value is a list of strings. Okay, so let's kind of right. If folks missed out on this, just kind of rewind to the very beginning of this lesson, right? We kind of played around with this big data structure. But let's talk about another one. All right, let's deal with organisms. In particular, let's say there are two categories of organisms, right? And Lisa, do you still have your hand up? Oh, okay, okay, all good. Let's say there's two major categories of organisms: plants and animals. Right? We're going to see nested dictionaries now. Right? This is going to be like our earlier one. Our earlier one we dealt with animals, but now we're going to kind of generalize them to organisms. Right? So I'm going to run this one right here. So this is a dictionary, right? But it's kind of nested, right? There's dictionaries within the values of it, right? For example, we have. Well, what do you think the length of this dictionary is actually? So if I were to say length of organism, right, how many key value pairs are in here? Yeah, yeah. What's the? Yeah, it's a little tricky. Yeah, someone in the Zoom says two. Yeah, it is two. Mhm. Yep, yep. Cool. Yeah, it is. So I'll ask this again, but with a different one. So organism is a dictionary, right, that contains two key value pairs, right? Key, a string, and then a dictionary, and another key and a dictionary, right? So there's two keys in the outer level of this dictionary. But let's kind of dive in, right? Let's index organism. Let's index the animal one, right? This is the let's look at it. So animal one, it's this one right here. So we're gonna so this is saying, hey, what is the value at the key animal? Right? So the value should be this whole dictionary, and we can verify that right here, right? I'll play this, and yeah, it is another dictionary. Right? We can once again verify with type. Right? You don't have to do type, but it just to kind of sanity check what we're working with. It is a dictionary. Okay, cool. So we got that. Let's kind of dive into here. Right? What is the length of this dictionary right here? Right? Organism, animal, right? So we're saying, hey, what is the length of this? Right? It should be how many key value pairs, right? Yeah, at least three. Yes. Yeah, thank you. Yeah. So if I do length here, it's three. All right. So the reason why I'm kind of asking this is because we're diving into the dictionary and kind of exploring how this structure is made. Right. So this is a dictionary, and it's going to get a little bit tricky now because we're going to use two sets of brackets now. Right. So organism, animal. Right. This. Yeah. Yeah. There are three key value pairs. Yeah. Because because organism, animal gives us the value this dictionary. Right. And then there's three key value pairs in there: lion, tiger, and bear. Yeah. Yeah. Exactly. Yeah. Yeah. We're diving into the dictionary right now. Yeah. Yeah. Good question. So yeah, let's use two sets of parentheses because things are going to get a little trickier, right? So if we just index the animal, this gives us a dictionary, right? But we can go deeper into it, right? We can go into it and maybe access maybe a bear, right? This should give us Ursus arctos. I hope that makes sense. Where we're diving in, right? This the way Python evaluates it is organism animal gives us a dictionary, right? And then we're indexing bear within that. This word, this is called nested dictionaries. Right? Similarly, if we did it with the plant category, right? Organism, plant, right? This gives us a dictionary of size 2. If you're curious what this is pointing at, it is this one right here. We're indexing this value. We're saying organism plant gives us this, so we can access two different values. Right? We can access redwood. Right, there we go. And then it gives us the final value with yeah the innermost layer. Okay. All right. Cool. And this should give us two right here because there are two plants that we defined. Yeah, two plants. Right, the redwood and the other one. Okay, and just like earlier, we can add new plants as well. Right, so uh, buttercup doesn't exist inside the plant dictionary. Right, this is going to give us a key error, right? Buttercup, because that doesn't exist. Right, see here, let's look at it. So let's look at it real quick. See, this is our current um, whole dictionary, right? But if we look at the plant one, right, it only has two key value pairs, right? It's got one key redwood and one basil, but a buttercup doesn't exist. So we can make it exist by setting it equal to something. Right, I'm just going to set it equal to the scientific name. Right, so this is going to this inserts a new pair. Right, so let's run that. Okay, it ran it, And let's go ahead and look at what plant looks like now. Organism, plant. All right, now we see there are 3 key value pairs within it. Right. Okay, so we're just kind of modifying the dictionary on the innermost level right now. Right, it does look a little trickier because we're using 2 sets of brackets. Okay, let's do some more. So our current dictionary, it looks like this right here. So organism, right? It looks like this. Right, we got plant, and then animal. Right, let's go ahead and add a new type of organism, right? A new type of category. Right, so let's say plant, animal, and then maybe fungus. Right, so first of all, a fungus doesn't exist, right, on the outermost level. The outermost level, if I were to say a fungus, right, this gives us a key error because, yeah, it doesn't exist. So let's make it exist by setting it equal to an empty dictionary. So this is saying, hey, make it exist, set it equal to an empty dictionary with these 2 curly braces. Okay, so I'll just run this. Okay, it did do something. It didn't display anything. So I'm going to make a new cell to display it. All right, so we'll go ahead and look at it now. Organism. I'm just going to run this cell just so Jupyter Notebook can display the value of it. All right, so now we look at it. There's 3 key value pairs on the outermost level. Plant, animal, and then fungus, which the value is an empty dictionary. And so we can go ahead and fill it in. Right? We can go ahead and fill it in by maybe adding a shiitake mushroom. Right? Like go ahead and go into fungus. Right? This is saying go into this dictionary, empty dictionary, right? And then make a shiitake mushroom. Shiitake. All right, so once again, this does not exist. So it's going to give us a key error. So we can make it exist by setting equal to something. I'm going to set it equal to lentinula edodes. Okay, cool. So we added it, and finally, the organisms looks like this right here. Right, we have another one, fungus, and we finally populated this dictionary, the innermost dictionary. Okay, and yeah, if we were to do the length of it now, the length of the whole wide one should just be 3, right? Plant, animal, and fungus. Okay. So yeah, data structures is very important. There's a whole class dedicated to this type of stuff. It's called CS21, I believe, right? Data structures and algorithms. So these data structures is kind of useful for the next assignment. All right, we'll jump into the next assignment and give some hints on it in just a bit. We got like 15 minutes left, so we have just enough time. So let's kind of summarize what we did. All right, we did the basics of dictionaries in the beginning. Right, we talked about, you can think of it as one-dimensional dictionaries. Right, this is one-dimensional because there's no nested dictionaries as values. Right, so we played around with creating, played around with adding, right, changing the size of it, modifying, right, reassigning, right, and then later on we took it another step up by making it kind of a 2-dimensional dictionary, right, or nested. And nested dictionaries mean that values of keys are another one. Okay, so we're kind of diving in, and once again, this is just like the JSON representation of a maybe some person's social media features. Right? This is how your data is mined. Right? If someone mines your data off of like Instagram or something, it's probably going to be in this format. Right? So this is a nested dictionary. We did this at the very beginning over here in the sneak peek. We ended up making someone's profile and setting it equal to this data structure. In the assignment, you'll see a similar data structure. In particular, I would like to kind of narrow down on a list within a dictionary. Right? So you can have a list within a dictionary, which we did at the very bottom. Right? So once again, the profile currently looks like this right here. Right? It's this person's profile. We can have a list within a dictionary. In this case, it's the children. Right? So we did that by looking at the children profile, children, right? Profile children. Oh, it's a key error. So it is case sensitive, by the way. This doesn't exist. It's case sensitive, so it's a lowercase c because that's how we initialized it. Right? This is a list. You're going to see this in an assignment. Right? When we dive down, we'll see a list. And how do we access? How do we index lists again? With the numbers, right? So 0 gives us that, 1, and 2. Right? So you'll see that later. But yeah, the whole goal of the past two lessons was to kind of see the differences between lists and dictionaries. I recommend kind of reviewing it and going back over the lesson if things need some more reinforcement. But yeah, lists and dictionaries. This is very important. Right? We're going to build on it, and a lot of the future assignments will rely on understanding these types of data structures. Oh yeah, no, we got enough time. Yeah, I can reiterate. Huh? Oh, okay. Here, okay. Yeah, here. I'll take a look at that after class. Actually, yeah, I did go over it a little fast. Yeah, my bad. But yeah, I'll check it out after class. But here, let's actually cover the sneak peek for the next programming project, and then I'll take some questions on that. Yeah, we got like 10 minutes, 10, 15. Yeah, that's just enough time. Okay, I'm gonna exit all of this. Don't forget to save it. The next assignment is called weather. The goal of this next assignment is to download weather data and print it out nicely. So when we download this data, it's going to be formatted as a dictionary. And the whole goal of the assignment is to access elements and print it nicely. So let's check it out. Let's go to the assignments, and then let's download this weather thing. Yeah, project week 3. Oh, by the way, the second project is due tomorrow. Project week 2. There's a good hint somewhere in the previous lesson. I think it was sometime last week. So yeah, make sure to review that previous recording. But yeah, as for week 3, this is due next Thursday. All right, let's download this notebook and upload it into our Jupyter lab. Okay, there we go. I downloaded it, and then let's go here and then upload it. I have my things organized. I have a projects directory, and let me just make another folder, another directory. I'll call it week 3 weather. And just go ahead and upload it right here. Okay, cool. Got it loaded up. All right. I'm gonna give folks a minute to load it up. We're gonna type a tiny bit of code, help folks get started on it. All right. There's gonna be some code that downloads data from the internet, and that data will be formatted as a dictionary where the key and value are organized as such. So this first cell, oh, before I jump into first cell, so this is the goal of the assignment, to write some print statements that display this right here. In particular, we're going to download data for the aptos, right, where Cabrillo is located. And the goal is to write a bunch of print statements that displays it like this right here, right? A bunch of lines. So let's see, how are we going to get this data? Right, well, the first cell over here, right, there's no need to modify it, or you don't really have to fully understand it. This first cell, all it does is downloads, it defines a way to download data from this website. Right? It's called openweathermap.org, which is a service that lets you download the data. So we're going to use that. Okay, don't worry too much about this. All it's doing is defining that. So I'm just going to run this cell. Right? And here we're going to use that function. We won't cover functions yet, but this is a function that retrieves that data. So this next cell will retrieve the data, and then, whoops, right, it's going to retrieve the data and then assign it to a variable called weather. Right, this variable weather is a dictionary. And the assignment will be exploring this dictionary and kind of accessing things within it. So let's play this cell. Right, this cell downloads. Okay, it downloaded it, and there's two print statements. Right, these next two print statements are really just showing that we can access certain keys within this weather. Right, once again, if to kind of visualize this a bit, right, let me make another cell. Right, this is like a playground cell, not a solution cell. I'm just going to write down weather right here. Right, so Jupyter Notebook will show us what the representation of this is. Right, so here it is. Right, the weather is a dictionary. Right, once again, I'm just going to prove it. Right, the type of it is a dictionary, so we can go ahead and access things within it. Right, for example, this is a key, right, title, and the value of it is the current conditions for today. Actually, right, this is not made up. This is literally, it's cloudy right now, and the icon, right, you don't have to worry too much about the icon yet. This is going to be used for a future assignment. So yeah, don't worry about this icon one. But temperature right now, it's a 287.58. Right, that is pretty hot. This is actually in Kelvin, I believe. So this is also a float, right? It's not an integer. So part of the project will be accessing this number and converting it to Fahrenheit, right? Because once again, the point of this project is to access certain values in this dictionary and print it out. Right? In particular, it wants us to print it out looking like this right here, right? Not exactly like this, because these are kind of hard-coded values, right? It's not raining right now. These are just made up. But it wants you to print it out like this, right? Current conditions, it wants you to access some value, and then it wants you to print out temperature, and then access some value, right? So that this value comes from the dictionary. Right? It comes from a dictionary right here, temperature, right? So you want to take this Kelvin temperature value and convert it to Fahrenheit. Right? Converting to Fahrenheit, it's going to be some formula. Right? You multiply by something and add something, I believe. But yeah, people kind of see what's going on with this. Yeah, so the solution cell is down here. You're going to put your name. And here, I'll help folks get started on this, actually. So let's help folks get started on this. Maybe a first couple print statements. Okay. Once again, the key value pairs can be displayed right here. Right. Well, we just saw this. Right. So this is basically saying the length of the dictionary is 7. Right. 7 elements, 7 key value pairs. Right. And it's going to be our job to access the values and display them. Right, so let's go ahead and display the very first part. Right, so the printout should look something like this. Right, the first print statement should say the current conditions. So let's go ahead and get the first print statement done. Okay, current conditions, rain. Okay, but don't exactly print rain there though, because this is just a made up value. Okay, current condition. So let's print that. Okay, this is the solution cell. We want to print current conditions and then colon, right, current conditions colon, and then, well, once again, a common issue I see on the previous submissions is people would just put like rain here, right? That's not what we want, because this is kind of like cheating, right? It's hard coding. It's hard coding the value as a string literal, right? We don't want to type it in there, right? We want to grab the current condition, because if we run this program another day, this the output will change, right? If you just put rain here, right, it's always going to be rain, right? If you run this in a year, it's still going to say rain, right? We don't want that. We want the value of what's in the dictionary. So the current condition can be accessed by over here by the key title. Right? This key title returns a value of the current weather condition. Right? So over here, if we access this key, right, it'll give us this value clouds. Right? So let's test that. So current conditions, our print statement, we can put multiple inputs here. Right? In this case, we're accessing the title, right? So weather, and then the title in here. Right, so let's run this, and there we go. It prints clouds. Okay, so this is kind of what we want. Right? Once again, we don't want to hard code it. We don't want to hard code it as a string, because we want to run this in the future. Right? You can run this like a year from now, and the output will change accordingly. Okay, cool. So we got the first print statement. Let's do the next one together, and hopefully that gives folks some hints. Okay, so looking at the example output up here, right? The next line, next print statement is the current temperature. Right, so let's print that current temperature, and then it's going to be the value in Fahrenheit. Okay. So current temperature. Let's get the next print statement. Print current temperature. Right, let's run that. Okay, cool. Hold up, let me scroll up just to make sure this output is looking exactly like what we want. Oh, no, it's just temperature, not current. Okay, so let me erase that current thing. Okay, there we go. We want to put the value of the current temperature, right? So once again, it is cheating to put it as a string literal, right? So some folks might kind of copy and paste this over here, and then they might convert it, and then paste it over here, right? So this is cheating. People see why this is cheating. It's well, first of all, this isn't even converted to Fahrenheit, and then second of all, this is cheating because it's hard coding the temperature, right? Like once again, if we run this in the future, right, the output will always be the same, right? We want it to rely on the data that we just downloaded. So don't hard code the temperature as a string, right? Instead, we want to access it from this weather dictionary, right? In this case, the relevant key value pair is over here, right? The key is temperature, which gives us a value 287. All right, so let's access that. Right? In the second input, right, let's access the temperature key. Temperature, there we go. Okay, cool. Okay, sweet. Cool, so it printed, and this is not cheating because it's using the actual updated one. A couple of things we need to do. We gotta first convert this to Fahrenheit. Right, this is in Kelvin. So luckily, we can do math on this because this is actually a float, I believe. Right? If this were a string, then it would be hard to do math on it. Right? But just to kind of verify that, if we go on our playground cell, right, let me just go to a playground cell. Like, let me just make one here. And this is just to kind of explore, right? So I'm just gonna put it here, weather temperature. Right, so this is 287.58. It is not a string, right? Meaning that it'll be easier to do math on it. Right? This is a type float. So we can probably do conversion. Right? We can convert it to Fahrenheit with this formula here. Right? The formula for conversion is right here. Right? So if we're converting from Kelvin to Fahrenheit, the formula is right here. Yeah, this very first one. This is saying grab the Fahrenheit. Grab the Kelvin temperature, multiply it by this, and then subtract this number. Right? This is a formula, and it yields temperature in Fahrenheit. And so let's do that. Right? Let's take the value of Kelvin and then convert it. All right. So let's do that. So I'm going to do that in the playground cell and then paste it into the output. I just kind of see what's happening. Right, so this is Kelvin. Okay, we need to first multiply it by 9 divided by 5. All right, let's do that. So this times 9 divided by 5. Right, the order of operations, it doesn't matter here because these will happen first. Right, so we do that, and we need to subtract this number, right, an offset. That's part of the conversion. So there we go. Okay, so we applied the formula to this number, and this is the number right here, 57.997 something something. Right, so once again, we want to use this right here. Right, we verify we can convert to Fahrenheit. So you can pretty much go here. Right, this is a number, meaning we can do math on it. Right, so there you go. Just did math on the number within the print statement. That this is possible. Okay, so let's test it now. So run it, and it says temperature is 57.97 something something. Now, you don't have to worry about the precision here. For this assignment, yeah, don't worry too much about this. There is extra credit on rounding things. I mean, not extra credit. It's just optional. You don't have to do it. Oh, so yeah, we just converted it, right? I believe it is 57.97 right now. Let me check. Checking my phone. Okay, yeah, it's pretty close. Yeah, it's pretty close. Okay. Oh yeah, where did I get the formula from? Yeah, there's a link to that right here. Yeah. Okay. One more thing we need to do, right? The printout should look something like this. Right? So don't forget the units. Right? We need to put an F at the end. So the easiest way to say F is just to put it as another input to the print statement. Right? So you can just do comma and then string F. And there we go. So it should print out the temperature as a F unit Fahrenheit. Okay, hopefully people are cool with this. We just did the first couple print statements for this assignment. Really all you're doing is accessing elements and values within the dictionary. Right? That's the whole purpose of this assignment. There's going to be some tricky parts though. I think the tricky part is going to be accessing the data structure. That there is a list within this dictionary. Right? Like if we look at the weather dictionary, there's a 7-day forecast over here. right? Like uh, the daily, if we access the daily key, it's going to give us a list of strings. Right? So this is probably the tricky part. Right? This is the last thing you're going to do in the assignment. Right? You're going to access a list. So yeah, give that a try because we're going to be required to print the 7-day forecast. Right? And try to make it as close to this as possible. Right? The grade will rely on how close it looks to the format. Right? Like make sure you have spaces here. Make sure there are units. Right? Make sure things are converted to Fahrenheit. Okay, yeah, so try to make it as close as possible. Okay, so other than that, we just ran out of time in class, so I'm gonna do some concluding thoughts and end class here. Okay, all good. Okay, so we just finished talking about data structures. Right, we just finished lists last week, and then dictionaries, and then fancier dictionaries. It might have seemed a little crammed, but hopefully folks can get the rest of this lab done. Right? We didn't get a chance to get the rest of the lab done, but the labs are actually meant to be done as homework. So go ahead and see if you can get the part 2 of this lab done. Right? Part 2 is asking us to kind of navigate fancy data structures. This is actually a prerequisite to finishing the assignment. Right? So please try to get this lab part 2 done, and it should make the assignment a little easier. Okay, I think that's it for today. Thank you all for coming. Have a great Wednesday, folks.